In today's video, we're going to discuss inverse functions and relations. As you can see at the top of the video, or at the top of the note page, we have two different objectives. First one, we are going to find the inverse of a function or a relation. And then, given two functions, we are going to determine whether those two functions or relations are inverses. So, before we can do any of that, we need to know what an inverse is. An inverse relation is a set of ordered pairs obtained by exchanging the coordinates of each pair. What do I mean by that? We switch the input, which is x, and the output, which is y. So let's look at an example number one. Example number one, or just the example, says that A and B are inverses, or inverse relations. So every x and y needs to be switched. This first ordered pair, 1, 5, and the inverse becomes 5, 1. So x and y are switched. Same thing, 2, 6. Switch x and y, becomes 6, 2. And then lastly, 3, 7 becomes 7, 3. So let's see if we can apply that idea to stating the inverse of the relation below. I'm going to give you about 15 seconds to see if you can do this one. Okay, you should have switched all of your x and y's. And there we go. That is the inverse relation to the one that was given. Besides inverse relations, we need to know inverse functions too. So the inverse of an equation. So we're going to look at that notation, and then we're going to do an example. Inverse notation, as we can see in this box. As with relations, the ordered pairs of inverse functions are also related. They're swapped. We can write the inverse of the function f of x as this. Okay, I want us to see this note to the side because it's important. That is not read as f negative 1 of x. That's read as f inverse, or the inverse of f. Negative 1 is not an exponent. This is just notation. It's not an exponent. Okay, so in example number 1, we need to find the inverse of the function. We can see the steps to the side. First step, we are going to rewrite f of x as y. So this is y equals 2x minus 4. The next step should make sense. What does the inverse do? It swaps x and y. It flips the input and the output. So that's what we're going to do. We're going to flip x and y. Now we need to solve for y. Okay, if we look at this, we have two variables. When we solve for y then, it's going to be in terms of x. So we're just going to have an equation in terms of x. We're not going to have a number. First thing I'm going to do is add 4. So I get x plus 4 equals 2y. If I divide by 2, we get y equals x add 4 over 2. Last step. If you remember, our equation started with f of x. So this y needs to be turned back. But it's not f of x, it's the inverse of f. So f negative 1 of x is equal to x plus 4 over 2. Or, another way to write that is 1/2 x add 2. So that's our final answer. Now, are these actually inverses? Let's show that they are. Let's show an example of how these are inverses. In this top equation, my original one, let's plug in a 0 for x. When we do, we get 2 times 0 minus 4, which is negative 4. If these are inverses then, that means in our inverse equation, we should have the point negative 4, 0. So let's see. If we do negative 4, add 4 over 2, we get 0 over 2, which is 0. So you don't need to check that, but that was to show us these are in fact inverses. That was just an example of one pair, but that's the idea. So these steps are the steps you're going to follow every time. We're going to do one more example together, and then you all will do one on your own. So let's flip the page. Example 2, it says find the inverse of the function. First step, f of x becomes y. Then we flip x and y. Note here, it's going to become y squared. And then we're going to solve for y. So we subtract 1. We get x minus 1 is equal to y squared. We have to think, how do we get rid of that squared? We're going to take the square root. Okay, let's remember though, from before, anytime we take a square root, we get plus or minus. We are not finished. Do not stop here. This y needs to be changed. We started with function notation, so our answer needs to be in function notation. The inverse then is equal to plus or minus the square root of x minus 1. Again, if you want to check, if you want to verify that these are in fact inverses, plug in a point. In our equation, if we plug in 0 for x, we're going to get a 1. So we need to make sure then in our inverse, 1, 0 is the point. And you can see if we plug in 1, we'll get the square root of 0, which is 0. So that does in fact work. Now, that doesn't prove that these are inverses, but it's a good way to check. We will learn in a few minutes how to verify that two functions are inverses. Moving on, here is the example for you to try. This is your example. There is more to this video, so I would suggest right now you pause the video and try this problem, and come back when you are ready to keep viewing. If you need another example, there will be an extra example at the end of the video. Okay, that was our first objective, is finding the inverse of a function or of a relation. We also need to determine, if we have two functions, if they are inverses. So that's what we're going to do next. Two functions are inverse functions if and only if both of their compositions are the identity function. Okay, identity function means what you put in, you should get out. Okay, so I know that that's a little complicated. Let's actually write this in notation. So what is the meaning? Both of their compositions, so one composition is f of g of x. The other one is g of f of x. If both of their compositions are the identity. Okay, so let's think about this. What this first notation is saying, I'm plugging x into g and then into f. So initially, I'm starting with x though. After all of that, I should get x back. Second one, again, I'm plugging x into f and then into g. I started with x, which means after all that, I should get an x as well. Okay, this is very specifically x. So if we end up with two compositions that are the same, it doesn't necessarily mean the functions are inverses. We have to have exactly x. Okay, so let's look at example 3. It says use composition of functions to determine whether f and g are inverses. We are told we have to use composition of functions. So our first step is to calculate or find the first composition. So this composition is taking g of x and plugging it into f. So g of x is going to go into f. So we have 3/4 x, but instead of x, we're putting all of g. Okay, we're going to have to do some simplifying here. So we're going to multiply those numerators. We have 3 times 4x add 24 over 4 times 3. I'm not actually going to multiply them because look what I can do. Those 3's will divide out. So what I end up with is that 4x plus 24 divided by 4. So 4x divided by 4 is x. 24 divided by 4 is 6. So I get an x. That's a good start. That does not mean that these two functions are inverses. That's a good start. We're not done yet, though. As we saw above, we need both compositions to be equal to x. So in our next step, we're going to do the other composition. So what this composition is saying is we're going to find f of x and put it into g. So f of x is going to go in for x in place of g. Okay, so we have 4x, but our x is going to be all of f of x. So we need to be careful here. Okay, order of operations. I need to simplify that numerator first. So what I'm going to do is I'm going to distribute that 4. When I do, I get 3x minus 24, and then plus 24 from here, divided by 3. Those 24's cancel, so we get 3x over 3, which is equal to x. So in this case, we are going to say yes, f of x and g of x are inverses. Okay, I want to tell us a quick note at the bottom of the page here. On an assessment, what I always see is the question will be asked, are f and g inverses? And what some people will do is they'll try to get tricky. And they'll say, you know what, I'm going to take f of x and I'm going to find its inverse. And so they switch x and y and they solve for y. So they get x minus 6 is equal to 3/4 y. Sorry, this should have been a negative. So this is a positive. And then they multiply by 4/3. And they say, that's equal to g of x. If we were to simplify it, it would be. And so they say, yep, they're inverses. Now what I'm telling you is you will not receive credit for this. The question specifically said, use composition of functions. You have to use composition of functions then. If you take one function and solve for its inverse, that's not going to matter to me. I'm not going to give you credit for that. So please make sure you actually use those compositions. Okay, let's move on to the next page. You all have an example here to do, and it's this example number 4. Use composition of functions to determine whether f and g are inverses. Okay, so what you're going to do is you're going to find f of g of x, and you're going to find g of f of x. And remember, you should get x. We don't care that we end up with the same compositions. What we care about is that we get x. So in this first one, you're going to take g of x and plug it into f. So take g of x, plug it into f. Okay, and this is where I'm going to leave you. There are 2 extra examples at the bottom of the page. These are optional. So if you are done and you have a solid understanding of inverses, you can stop the video and make sure you do those 2 extra problems. But if you want to see these extra problems down below, please stick with me. Example number 5, we need to find the inverse of this equation. First thing, f of x is going to get replaced by y. Then we're going to flip x and y. Now we need to solve for y. Okay, so we need to be careful here. If I look on the right side of the equation, there's a bunch I need to get rid of. There's a square root I don't want, a 2 I don't want, and a 1 that I don't want. I need to start with the outermost root. So to get rid of that root, I'm going to square. Both sides get squared. So we get x squared is equal to 2y minus 1. Now I can add 1. So we get x squared plus 1 equals 2y. Divide by 2. So we get y is equal to x squared plus 1 over 2. Now, remember, we are not finished yet. We started with function notation. Our answer needs to be in function notation. So our inverse is equal to x squared plus 1 over 2. You could also see that written as 1/2 x squared, add 1/2. Either one is correct, but it is important for us to be able to identify both of those, to know that they're equal. Example number 6 is one where we are determining if the functions are inverses. So determine if f and g are inverses. So we are going to start by finding f of g of x, and then we'll find g of f of x. This first notation, I am taking g of x and substituting it into f. So g of x is going to go into f. So I get 4, instead of x, I'm going to write all of g. Distribute that 4, so we get 4x minus 7 plus 7. Those 7s will cancel each other out, and we get 4x. Okay, what did we need if these were going to be inverses? If these were inverses, that composition should have been equal to x. It's not, though. At this point, we don't even have to go on and do the other composition. We can right away say that these two functions are not inverses. Not inverses. Now, you can go on and still compute the other composition, it's just not necessary. So hopefully those last two examples helped solidify things for us. If we have any remaining questions, please make sure you write them down or send me an email, ask in class, or come to office hours.